Hello class, welcome to 1.5 dividing whole numbers. Our focus here would be on these objectives: dividing whole numbers and introduction to the notation and how to divide single digit numbers, and then when you have a long division, how to perform that, and when you have a remainder in a long division, what to do, and also to do with applications. To start with notations, we have operation symbols for division. Just like multiplication, you've got multiple ways of denoting division. You have the division symbol, right, with a dot up, a line, and then a dot below. Then you have the bar, the division bar, like A over B, as you see here. You also have the division symbol like this, where B is on the outside and A is under the division symbol. We also have the A/B. Okay, so the division is like a slash. Now you must understand how these symbols came to be. So a little bit of history of math will reveal to us that centuries and centuries and centuries ago, when civilizations were beginning to flourish, there was the need for transaction and trading and all that. And so in order to, as communities were being built, and to make sure that the interaction and the translation of goods was understood by everyone the same way, that led to the need for numbers. And the need for numbers, of course, led to the need for computing with numbers. And remember, these were very advanced people for their age, right? Given the ancient lives that they led, they were pretty advanced in mind, because I personally feel they didn't have all the clutter of the world. They were able to live so close to nature that they could look at the stars and understand how stars work as a clockwork, and the skies and the rotation of seasons and everything. Everything was a mathematical a formula for them. All they had to do was decipher it. And so, it was amazing to see how, for instance, when they had to cross the river Nile, they actually, the tribals, the Egyptian tribals there then, we call them tribals today, but they were the original inhabitants. They used similarity of triangles, a geometrical concept, to gauge the distance, and that's how they crossed the river Nile, it is said. And the very idea of angles, you can see that in their architecture, in their tools, and because it was all trial and error, and then when they saw that at a particular angle they could get a nice strike, or if they were able to split something, or it was just easy on their hands when they were able to use a particular angle. That's how certain rocks and stones, and they were chiseled to form into these weapons or tools for their hunting and agriculture. So it's amazing to actually connect math with the ancient background it has. The Sumerian culture, the Mesopotamian culture, the Indus Valley civilization, all of them utilized mathematics heavily, the Egyptian civilization as well. All right, so as we progressed, you see the last one, the slash. This slash is basically to accommodate typewriters and calculators and then computers, because you could not do the two line, like for all of these things, you had to use either special characters or you needed two lines to actually allow that character to fully display. And so the slash was a quick way to show division. Nevertheless, notice how the order again here matters. This is just like subtraction, okay? So this is subtraction, but basically done quicker in a sense. It's also more closely related to how to share. To divide means to share, right? So if you really love to share, you should really love division. If you once understand how division actually works, it is as easy and as intuitive as addition is for most of us. Okay? The language here is quotient. Remember again, we saw that for addition, they call it the sum. For subtraction, it's called the difference. The result. For multiplication, the result is called the product, and for division, it's called the quotient. So the quotient of 12 and 4 would be 12 divided by 4, as you see here in words. Okay. Now there is a specific way in which we do the division, but to give you how division and multiplication are connected, just like how addition and subtraction are connected, one is indirectly helpful in finding the other, you also have the same thing with division. So if we say divide 42 by 6, okay, if they give you in words like this, you can translate this information as 42, this symbol, division symbol, 6. Or 42 goes inside. What is on the front goes inside and 6 goes outside. Or you could show it as 42 division bar or fraction bar 6. And then there's one more, 42/6. So no matter what symbol we use, we can find the answer by using multiplication. So then what you're saying is you take this number that is being divided, you take this one, right? In each case 6 is what is being divided. So you take that 6 and you ask yourself 6 times what will give me the 42. Just like how we did for subtraction, when we did the subtraction we'd use the check to add the last 2 rows to get the first one. So also here you take the 6 that is being divided and see 6 times what will give me 42, and again you are getting strong in your multiplication, so you should be able to identify that 6 times 7 is what gives you 42. So 7 is the answer. So you can then say 42 division 6 is equal to 7, and you can box the answer. So this is an indirect way of dividing by checking it through multiplication. Okay. Now this is just an easy, quick way perhaps, but remember this is not ideal. Okay, you cannot do this every time because you know, in some cases where it doesn't divide evenly, you won't be able to find the answer that easily. Okay, so let's keep that in mind. We can still do these kind of problems because of with the help of multiplication. In fact, a lot of things we do in division, we will actually go through the root of multiplication. Okay. All right, let's look at some properties before we actually do the division. So we have division properties of 1. Okay, remember we have 1 and 0 seem to be doing a lot of things for us. So we need to see how this works. Now, we did not have any properties for subtraction. We did have properties for addition and multiplication, and they were very similar. Now, for division, we also have something similar to that, but understand this is division. Therefore, we have 2 things, okay, happening. So if I had some number, let's say 6 divided by 1, okay, 6 divided by 1. So think of it as sharing, okay. So you're sharing 1 item, okay. So we have 6 divided by 1 to be 6. And then we have 6 divided by 6. You have 6 things and you're dividing it among 6 people. What will be the answer? Each one gets 1. So 6 divided by 6 is 1. Okay. So you have 6 things that you're dividing with 1 person. Okay. So let's use pizza for an example. Okay. So this will be 6 pizza slices, and this will be the number of people. So 6 pizza slices for 1 number of people, so 1 person. So that will be 6. So here you have 6 pizza slices and number of people. What does this mean? You're dividing the 6 slices with over 6 people, so each one gets 1. That's the whole idea of sharing. That's what I mean by, if you love sharing, then you can do dividing. Okay. Well, the story. So this is going to be true for this is the property of 1, right? So this is going to be true if I had any number divided by 1, that will give me a 6. Any number divided by itself will give me a 1. Okay, that's the rule. Again, because it's division, we have to be a little careful. When I say any number, we are not considering 0 in the second scenario. Okay, so let me change this to a general format. So A is any number A is not equal to 0. This is a restriction, a condition, we say. And that is actually, this condition is important here. Okay, it doesn't matter for the first one because 0 divided by 1 is 0. That's not a problem. So 0 divided by any number is not a problem. But 0 divided by 0 is a problem. Okay, so I'll just make a quick note here. Okay. Note 0 divided by any number is equal to 0. 0 divided by 0 is undefined. You really, unless you reach calculus and you have a way around it, there is really no way to handle this 0 over 0. Likewise, any number over 0 is undefined. Okay, I say any number with the understanding that you are not going to choose 0 because 0 over 0 is undefined. I mentioned that. So 0 over any number that's other than 0 is totally fine. Okay, so 0 over 1 will be 0, 0 over 10,000 is going to be 0, 0 over 59 is 0. But 59 over 0 is undefined, 1 over 0 is undefined, any number over 0 is undefined. So 0 in the denominator is a bad thing. 0 in the numerator is a good thing. Yeah. Okay. So then because of this note, I'm going to bring in a quick definition for the property. So division properties of 0. So 0 over any number, right? So 0 division any number A is 0. But A division 0, A is some number, right? So any number, some number divided by 0 is, or I should say is, not equal to, is undefined. Yeah. So bear that in mind when you do those type of problems. Whatever symbol they come in, you just want to check that out. Okay. Now let's try division, regular division. Okay. Now previously we saw dividing in terms of multiplication. Here we're going to do the division and then check by multiplication. Divide 2596, division symbol 4, check by multiplying. So this is called the long division method. When we say long division method, don't feel that it's going to be very long. It's just that it goes vertically down like we did in all other problems, and because of the style in which it's set up, it goes long, and therefore it's called the long division. Okay. So let's write out. For long division, there's only this preferred symbol that we use. 2596, right? I have intuitively used this symbol that I really don't have a name for this symbol. I don't think the book has any specific name for this though. But anyways, so we use this kind of notation, okay, to do the long division. So you're not going to use the slash, you're not going to use the division bar or the fraction bar. So you're going to use this. And this is really, really nice because it's vertically set up to help you do the calculation. Now remember that for multiplying, we did multiplication of partial products. So we took them digit by digit and we multiplied them and then we added them. Here it is the reverse, right? Division will undo multiplication. So we're going to do the other way around. So we're going to divide and then subtract. There we multiplied and then added. Here we divide and we subtract. So then we are looking at this number 2. You're seeing if 4 fits in 2, how many times? Now 2 is too small for 4 to fit. So you go into the next number. Together you see it as 25. 4 will fit in 25 how many times? That's the question. So you have to be pretty strong in your 4 times table. And so you keep doing, okay, 4 times 4 is 16, 4 times 5 is 20, 4 times 6 is 24, we're getting close. 4 times 7 is 28. So 4 times 6 is 24. So you don't get a number that's exactly 25 for 4, but you do get a number that is closest, but it has to fit within it. So it can't exceed it. So 4 times 6 is 24. So let's do that. So what you'll do then is you are looking at this 25 and let me use the blue itself. So 4 times 6 is 24. And then you do the subtraction, the minus. Okay. So 25 minus 24, you can see it as that, or you know how we do it individually, right? 5 minus 4 is 1, 2 minus 2 is 0. So that is good. So now you look at this 1. How many times does 4 fit in 1? Oh, 1 is too small. So we bring down the next number, 9, and we make it 19. So you ask yourself, 4 will fit in 19 how many times? Once again, do the routine. 4 times 3 is 12, 4 times 4 is 16, 4 times 5 is 20. 20 is more than 19, so you can't use 4 times 5. You'll have to use 4 times 4, which is 16. Once again, subtract it. 9 minus 6 is 3, all good there. 1 minus 1 is 0, so that's also good. Now we try to see how many times 4 fits in 3. 3 is too small. You know the drill by now, so bring down the 6. You have a 36. So you're going to ask yourself, 4 times what will give me 36? Is that an exact answer? Does 4 fit in 36 exact number of times or not? So, so once again, you know, we just saw 4 times 6 is 24 previously, right? So go ahead and use that. 4 times 7 is 28. 4 times 8 is 32. 4 times 9 is 36. Well, that fits exactly because when you subtract it, you get 0. Okay. So now if you look at the parts of your division in this setup, this here is called the quotient because that was the answer. Right? This part here, this is called the divisor because this was the one that divided it. What did it divide? That will be this number. This is called the dividend. Okay. This is the dividend which goes under the division symbol, and the divisor goes outside the division symbol so that it is used to divide. And in the end, if you got any left over, in this case there was nothing left over, so 0 is what you got. But if you got any other number, say 36 and 35, then the leftover would be 1, right? That will be called the remainder. You really want to remember these positions, okay? Dividend, divisor, quotient, and remainder. These are the 4 parts that we use in division, log division. They asked us to actually check by multiplying. So what will you multiply? So when we check by multiplying, let me take you back a little bit. You want to multiply the quotient and the divisor to see if you get the dividend. Okay, so let me write that out here. Quotient times the divisor should be equal to the dividend. This is true because the remainder is 0. So when the remainder is 0, this is what we do. Okay, so this is going to be pretty easy in the sense you don't have you have to multiply. You're not dividing again or doing something. And of course, the check is by multiplication, so no confusion there. Let's look at the quotient. Quotient is 649. Divisor is 4. So times 4 is what you should be doing, and we should be able to get the dividend. So let's first put it vertically. 9 times 4, 36. 4 times 4, 16. 17, 18, 19. 6 times 4, 24, plus 1, 25. 5 expand. 2596. Let's see if that was the dividend. Yes, 2596 was the dividend. So we got that. So our check is good. Okay. So that is really cool. You were able to do that. Okay. So you're able to check by multiplying. So whenever your remainder is 0, we have absolutely no problem with the check part. Okay. Now let's do a problem where we might expect a remainder. Okay. So it says divide 1, 4, 3, 9, division 4. We will also check it by multiplying in the end. Okay. So let's do the long division. So we have 1, 4, 3, 9, long division. That goes inside the dividend, right? So let me just put that here. This is the dividend. And this is the divisor. So the divisor is 4 again. Let's use that. And let's start with 1, too small, so we go for the 14. 4 times 3 is 12. Okay. Because 4 times 4 will be 16, it will go over. Then do the subtraction. So 14 minus 12 is 2. Or you can also see it as 4 minus 2 and individually. Okay, so let me use a different color here. The subtraction, 23. 2 is too small, so I bring down the 3, right? So then we have 4 times 5 will be 20, because 4 times 6 will be 24. Again subtract, and that will give us 3 here. Bring down the 9, 39, and then we have 4 times, we just saw that, 4 times 9 will be 36, so that will be a 3. So if you again go back to see what these ones stand for, this is your quotient, and this is your remainder. So there was a remainder, and there is no more number to bring down, so 3 is where you stop. So the quotient and the remainder stand there for us. Okay. So this is what we have to do when we have a remainder. Okay. So the check would be quotient times divisor. We did this, right? So you have to do this first, and then plus the remainder. If you add the remainder to what you multiplied, that should give you the dividend. So let me again point to you that this is the dividend. We already wrote that in red, but just for a quick clarification. So 359 times 4. So this is what we're trying to do here. 359 times 4. 359 times 4. You need to do this first, plus the remainder 3. Okay. So 359 times 4. Let's do that. 9 times 4, 36. 3, 20, 5 times 4 is 20, 23, 4 times 3, 12, 13, 14, so we got that, plus the remainder 3, 6 plus 3, 9, 3, 4, 1. Now this is what we have as the dividend. If you go back to our problem, dividend was 1439, that's what we got, 1439. Okay, so when there is a remainder, if there is no remainder, there was nothing to add, right? So you would have added a 0 because the remainder was a 0. But here you have a remainder that's not a 0, and therefore that addition really matters, so that it will adjust for the remainder. So what they do is usually the answer, when you present the answer, what was the question? 1439 divided by 4 is equal to, and then when they write the answer, you can write it in one of two ways. You can say 359 or 3, okay, to say remainder 3, or you can put it in words, okay, with a remainder of 3. So we can box this. Okay. Now, as we move into word problems, let's try to look at some of these notations and what they mean in terms of expression. So we can use the language as divided by, quotient of, divided into, and then let's look at the example and the expression. Okay, so 12 divided by 4 means 12 is the dividend and 4 is the divisor. 4 is the one that's going to divide. So you see it as 12 division 4. The quotient of 12 and 4, once again, the order, just keep the order as it is, 12 and 4, 12 and 4. 4 divided into 12. Okay, notice how the language is switched around. Not by, but it says into. 4 divided into 12 would mean that you are dividing the 4. 4 is the divisor basically, and 12 is the dividend. Okay. So we'll do a couple of long division problems that involve larger numbers, and then take on a word problem. So let's take this division problem. 74521 divided by 241. Yes, it does look long, and you're going to do all this without a calculator. 241. So you know right away that you need 3 digits here to see how many times it fits in it. Okay, so you are, 241 times 1 is 241, but you have to do 241 times 2. 2 is 8, 2 times 2 is 4. No, it's still too small. You can do estimation, right? You can estimate it. So you can keep it as a 240 or even 250. Well, you can even keep it as 200, the 241, round it to 200, and see 200 times 2 will be 400, right? 200 times 2. I remember I told you the trick to forget about the zeros. 2 times 2 is 4, 0, 0. So when you keep it as 200, it's a whole lot easier. So what do you think is 200 times 3? 600. 200 times 4 will be 800. So you know it is going to be somewhere between 3 and 4 because it's not 200 but 241. So that is how you decide what number you want to choose. So then I'm going to try 241 times 3. 3 times 1 is 3. 4 times 3 is 12. 3 times 2 is 6 plus 1 7. 723. It's so close, you know that if you did 241 times 4, it will definitely exceed 745. So we kind of eyeballed it with estimation, and so that makes the division a whole lot easier to track through. 723. Remember, we have to do the subtraction. So 5 minus 3 is 2. 4 minus 2 is 2. 7 minus 7 is 0. Okay, so 22. So bring down this 2. Now 222, and you have 241. It's very small, right? So 222, you brought down 1 already. That doesn't fit. When it doesn't fit, you don't just bring down the next number, but before you bring down the next number, you have to put a 0 because it's basically like this. Okay, so 241 times 0 is 241. So that means you did a step here with the subtraction. That gives us 222, right? It's like you did that step. So there is a 0. And then you'll have to bring in the next one. Do you see that? If You don't bring them right next to each other. When you do that, you have to bring in that 0, but when you do it like this, you will not miss out on the 0. So you have 2221. It's a 4-digit number. So again, try the trick with the 200. So 200 times 4 will be 8. 200 times 5 will be 10. 5 times 2 is 10 with the 2 zeros. Okay. So you need to go twice as much, right? Because you're here in 2000. So 200 times 10, is going to be 2000, right? 2 times 1 is 2, the 3 zeros. So 200 times. So 200 times 11. Think of that. 200 times 11. So 200 times 11 means 11 times 2 is 22. 2200. So you were very close. Now you're thinking, it should be, it seems like it's going to be somewhere there, right? But if you look at it, you are actually looking at a larger number, right? 241, not just the 200. So it's going to be somewhere close, like there is a 10, then there is 11. So if you're not sure, let me just do it on the same side. It gets too cluttered otherwise. I want to try 241 times 10 because that's easy, right? You know what that is. You don't have to compute. It's going to be 2410. Right there, because it's not a 200 but a 241, you notice that that goes over what we need. 2410 is way over this. So you have to do it as 241 times 9. So our estimation at least brings us closer to the number. In our estimation, because we estimated it, we rounded it so low, 200, you were able to look at numbers that were more than 10. But here, this is the actual numbers. So 9 times 1 is 9, 36, 3, 9 times 2, 18, 19, 20, 21. 2169. So 3 or 9, right? 3. So there's a 9. 2169. Okay, so you have to do the subtraction. 1 minus 9, too small, so I'd make it 11, right? I borrow a 10 from there. 11 minus 9 is 2, because I borrowed 1 from there. The 2 will go down as 1. 1 minus 6 not enough, so I borrow 1 from here. So that's another 11. 11 minus 6 will be a 5. 1 minus 1 is 0, 2 minus 2 is 0. So 52 is my remainder. So the answer would be 309, remainder 52. However, I need to check it, so let's check it. Okay. So 309 times 4, you have to multiply the quotient with the divisor. So let's do that. Oh, it wasn't 4. What was it? It's a 3-digit number. 241. 241. Oh, that's a lot. I need more room. Times 241. 9 times 1 is 9. 0 times 1 is 0. 3 times 1 is 3, right? Then you put the star and go for the 4. 4 times 9, 36. 3. You actually can bring down the 3, but because you know that 4 times 0 is 0, plus 3 is 3. 4 times 3 is 12. Then you are at the 2, so star here and a star here. 9 times 2 is 18. Again, don't get confused. Okay. So 2 times 0 is 0, and bring down the 1. 2 times 3 is 6. So that's a 9, 6. 3 plus 3 is 6, plus 8, 14. 1, 3, 4, 7. Okay. So our multiplication was really long, so I'm going to stop there and show you the next step. 74469 plus this 52, which was the remainder, right? Let's do that. 9 plus 2, 10, 11. 1. 6 plus 5, 11, 12. 4 plus 1, 5. Then you bring down the 4, bring down the 7. Let's check. I almost forgot what the starting number was. So I have 74521. There you go, 74521. So we got the check working. Because we had a remainder, you had to multiply the quotient and the divisor, and to that sum add the remainder, and that gives you the dividend. So we got it right. now that we've seen long division, we are now ready to go for a word problem. So let's look at this example. Okay. We have Cecilia bought a 160-ounce box of oatmeal at the big box store. She wants to divide the 160 ounces of oatmeal into 8-ounce servings. She will put each serving into a plastic bag so she can take one bag to work each day. How many servings will she get from the big box? So you'll have to imagine this scenario, right? Read and reread until you understand. This is the big deal with word problems. We always get nervous when we see word problems, and particularly when they look as big as this. We think we panic first and then we lose all sense of control over the problem. Okay, I mean, come on, there's really nothing to fear, because word problems actually are our friend, because we can relate to the problem. It's not abstract, it is something you can imagine, and you can figure out, what would I do if I were to do this? You know, if you're watching your diet, if you want to make sure that you measure what you eat so that you can keep track of a log, food journal or something, people do this, right? If you go to a nutrition or a dietitian, nutritionist for nutrition counseling, or to a dietitian, then you have guidance from them that will sound very much like this. Okay, so that doesn't put us off, because then we ask them what it means and how we can make healthier choices. So come back to the problem, read it and reread it. And whenever your mind tells you to panic, you have to confront that fear and say, no, I'm done with being fearful of these things. I will no longer be a victim to all these things. Okay, enough of all this feeling sorry for yourself or saying I'm bad at math. Enough of that, okay? I mean, there's a reason why we're taking this course. We want to get better at math, not, keep saying we're bad at math. So for a change, why don't you say, I'm going to try this and see that I get good at this math, because that's the growth mindset. That's the positive mindset. So read the problem. Let's read it again. Cecilia bought a 160-ounce box of oatmeal. So if you can't visualize this, go run and grab a box. If you have a box, you can see the measurement there, right? So it gives you a tangible experience here. She wants to divide this 160 ounces of oatmeal into 8-ounce servings. So if you look in the box, it will say one serving is equal to what, and so on, right? So that's basically what she's trying to do. She's trying to reduce it to 1-ounce servings so that she can divide it into that many servings and separate them and pack them separately so she can take to work each day. And so that is exactly what we're trying to do. So if you figure this out, then, there are ways you can visualize this. I'm not an artist, you'll know that very soon when I start drawing. Okay, so we have the cereal box. And it says 160 ounces, right? This is how it says. And she wants to break this into smaller packets. Okay, 8 ounce, 8 ounce, and so on. And we're saying, how many such packets will she have to break this into? Now, when you visualize it like this is a simple word problem, so you probably know the answer. You saw the answer right away. But I'm just giving you a kind of a strategy to think through word problems, however they may appear. Okay. So then I have to divide, and there was the word divide. So you have the clue in the problem too. Okay. So she wants to divide this 160. So divide 160 into 8 ounces. Okay. So 160 divided by 8. You can put it like this, 160 divided by 8. I like to do short division. This is long division, right? Short division would be like this. 8 times 16, right? I mean, 8 times what is 16? 8 times 2 is 16, and I put a 0 right there. That's short division. It works for some problems. It's the ones that are simple like this, that are divisible. If not, you can go the long division method, which is always safe, right? Because you've been doing that. It works for all kinds of problems. So 8 times 2 is 16 minus, you get a 0. there is a 0 that you bring down, but you don't, that 0 is meaningless, so you take that 0 up here. Okay, remember how we did that? So if you want to actually see that step, that's a 0, so 8 times 0 is 0. This is how it looks. But we saved that one extra layer of steps by bringing up the 0. Okay. Either ways, your answer is 20. So she has to divide into 20 servings. Okay, so that she can take a serving to work each day. She can take one back to work each day. Each serving for her is 8 ounces. Right. The only problem I have in this problem is that she's putting them in plastic bags. Actually, I have two problems. One is that she's eating cereal, and the other one is she is putting it in a plastic bag. But I think it was not a cereal, but it was oatmeal, so I will take that back. Make sure that it's not flavored oatmeal, because that's going to have tons of sugar to make it flavorful. Okay, I think I'm going into a different lesson other than math here. Alright, but I just want to, I always think through these problems to see how much I can take from this into my life. And oatmeal is a good choice, but again, what kind of oatmeal is another choice. And secondly, don't put them in plastic bags. Try to avoid plastic. Go for glass or stainless steel boxes whenever possible. Okay. Alright, Cecilia. Sorry. Cecilia, you may be taking this to work. I hope you're making good choices. So Cecilia will get 20 servings. Or you can say 28-ounce servings. From the big oatmeal box. All right. So as I mentioned, try to do a storyboard like I did. We call it the storyboard, where you kind of draw the story that you hear in the problem and then try to figure out how to respond to it. Sometimes you may see the need to bring in a formula because of, say, a geometrical shape or something, or some other relation that has a pre-existing formula. Or, sometimes it just clicks to you right away, where you do the problem and then you use some other means to cross-check your answer. Nevertheless, whatever method you choose, you really have to do the math part of it, which is you have to show the math part. Here in this case it was division, and then you'll have to write the statement and box the answer with the numerical value and the unit of measurement. Alright class, I hope this was helpful. You got a few tips here and there other than math. I hope you'll bear with me on that. I will see you in the next video. Take care.